You can fit 6 graphs on one side.
Okay, now, are we listening? Here we go. In order to graph cosecant and secant, you have to be able to know how to graph the cosine and sine. So every time I see cosecant, what I'm actually going to be graphing is I need to, in my head, first graph the sine of 2x minus pi. Do we all understand that? Whenever I see cosecant, I need to say, okay, I need to graph sine before I can graph cosecant. So let's go ahead and go through this material and go ahead and graph sine. So step one, what do I do this? What do I have to do first? What do I get out of here first? Come on, we're looking for A, B, C, and D. What's A? A is your amp, right? My amplitude is going to be plus or minus 1. From my amplitude, what do I get out of that?
Your maximum.
Your max, your level, and your min, correct?
This is for cosecant or something?
For both. Your max is your positive amp plus C. Your level is 0 plus C, and your minimum is your negative amp plus C. What is C here?
0.
0. So am I shifting this thing up or down? No. So what I'm going to have here is going to be positive 1, 0, and negative 1. We all understand why that is that way. Why it is like this. Because it's your amp. It's your amp, right? Okay, from here, now what am I going to be looking for? My period. Well, what is the typical period for sine and cosine? 2 pi divided by absolute value of b. Here's where many of you struggled on the test. You guys don't know where b is. Where do we find b?
Right after X.
B is the number attached by multiplication to the angle, which is x. Do we understand that? The angle is x. So what's attached to x by multiplication? The 2. That's your b value. Just to make sure and clarify anybody who's confused on that. So 2 pi divided by 2 is going to give me pi. What does this mean to have my period be pi units?
Because one,
No, it's going to end at pi.
every half is full.
Full cycle.
Yeah.
So in other words, what this means is I'm going to complete a full cycle, max level, and level max. And within pi units, which is going to be a semicircle. Do we all understand that? So what we're doing is we're shrinking this thing down. In other words, my adrenaline is up, right? I'm excited because I'm completing one cycle in half the time that I normally do. We understand that, yes or no? Okay, now, what do I need to find next? I need to find my interval. My interval is going to be your period divided by 4. So it's going to be pi divided by 4. What does that help me do here? It helps me land on my axes every time so I get those nice, easy numbers to graph. Okay? Now, after this, what do I need to find? Starting point, ending point. So my starting point is going to be the junk in the parentheses. Why is it junk in the parentheses? Because that's going to be your B and your D. So that's going to be 2x minus pi is equal to
0.
0. And my ending point?
2x minus pi equal
2x minus pi is equal to
Pi.
2 pi. Now, if we solve these things, what's going to happen is I'm going to have 2x is equal to pi, which means x is going to be equal to pi over 2. Over here, I'm going to have 2x is equal to 3 pi. To have x is equal to 3 pi over 2. Now, how do I know that this is correct? What's the formula to figure that out every time? There is pi units between there, but what is the significance of that pi? If I take my ending point and I subtract my starting point from that, that's going to give you my period. It should, so I have 3 pi minus 2 minus pi over 2, and that's going to give me 2 pi over 2 to give me the little pi units, which is my period. Do we all understand that?
Yeah.
It should be like that every time. Your starting point to your ending point is going to be the number of units in your period. Yes?
I'm confused as to why we have to write down y equals sine.
Because in order to be able to graph the cosecant function, you have to first graph the sine. We're going to get there. So we're just going to keep on going here. We're going to graph that function. So if I make a little xy table, and I'm actually going to put sine up here so that we know which one we're graphing at this point. I'm going to start where? Where's my starting point? Pi over 2. What am I adding to pi over 2? Pi over 4 units. So pi over 2 is 90 degrees. If I add another pi over 4 to it, I make pi over 2. What is that angle? 3 pi over 4. If I add another pi over 4 units to that, pi. If I add another pi over 4 units to that, 5 pi over 4, add another 5 pi over 4 units to that.
3 pi over 2.
3 pi over 2. Can you see the visual in your head of the unit circle right now? Do you see it being sliced in that 45-degree angles every time? Okay. Now, according to sine, my question is, this is the graph y equals sine of 2x minus pi. Is this thing reflected? No, my amp is positive, which means I'm gonna have, what is this thing gonna look like? It's gonna look like what?
Double thing.
Level, max, level, min, level. Do y'all understand that, yes or no?
It's gonna be off.
Now, no, it will not be the opposite. So what we have going on here, what was my level? 0, my max was 1, level 0, min is -1, and 0. So if I graph this thing, I'm going to start at pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. Here's going to be 1, here's going to be -1. Correct? At pi over 2, we know it to be 0. Then we have a max, 0, a min, 0. Here is my lovely little sine graph. Do we see that, yes or no? That's my sine graph. Now, we're not graphing sine, are we? We're graphing cosecant. No, it's not. When we graph the cosecant, what's going to happen is all of your levels are going to turn into asymptotes. Why? Because it's undefined there. And if you look at your lovely little unit circle, and if I ask you what the cosecant of 0 degrees is, the cosecant of 0 degrees is going to be your y value. That's your sine. So the cosecant is going to be what? 1 over y. Do we all understand that? So what's going to be my cosecant here? Undefined. Do we see that? Do we understand that? So here I'm going to have 1 over 0. That's going to be undefined, which means that's my asymptote. If I come up here, I'm going to have 1 over 1, which is going to be 1. If I come over here, I'm going to have 1 over 0, which is going to be my asymptote. 1 over 0, asymptote. Right? See that? It's check. What is sine? Your y value.
Yeah.
What's cosecant? The reciprocal of that. 1 over y. So all you're doing is you're doing 1 over the y value. 1 over the y value. 1 over the y value.
I'm confused to like why we're doing this.
Because where do we get all of our values from? Which are all from our axes, right?
Yeah.
What I'm asking you is what is the cosecant at 0 degrees? Well, the cosecant at 0 degrees is 1 over 0, which is going to be undefined. Undefined graphically represents a hole. Okay? A hole in the graph. Well, whenever we have a hole in the graph, what we're going to have here is actually an asymptote there because it's never going to cross the graph there. It's going to get really, really, really close to it. It's never going to cross it. So we have asymptotes at all of our levels. Okay? So if we come back here, what we're going to look at here is we're going to put an asymptote here, an asymptote here, and an asymptote here. Yes, you have to draw those on your paper.
So just make that graph and put that on.
We're not done. Okay, what happens is your lovely little levels become asymptotes. Okay, now what we have is that the maxes, we now have a parabola opening up. We have a parabola opening up, which means that max is actually going to be a minimum vertex, which means it opens like that. Can we see that? Over here, our minimum down here, again, is going to turn into a maximum vertex. And the blue is actually what your graph is for cosecant. It's not difficult. All we're simply doing is changing all of our levels to asymptotes. and then our level zone max and min turn into vertexes. Right? Our max and min turn into vertexes. So if I were you, whenever we're doing our XY tables, instead of having that middle one where I put in there, if you want to plug and chug, you can. But if you want to make that middle the sign of the cosine so you can get what I have up there, that's fine. That's totally fine. So in there, on your paper, where it says the machine part, where it's plug and chug, if you want to make that the sine or the cosine so that you're able to understand what it is, you can do that. Now let's look at this thing graphically, so that you guys all see these. You guys are freaking out over nothing. I mean,
Man, this is.
I'm glad that is. So if I graph this thing, if I graph the sine of x, that's my graph of sine. Do we see it? Now, if I hit tab here again and I go ahead and I graph the cosecant of x, do we see it? That's all it is. If I want to look at it from 0 to 2 pi, so that you can see one complete cycle, this is going to be 0, and this is going to be 2 pi. And then our scale is going to go pi divided by 2. That's it. That's what you're going to see. Do you understand that?
That's it.
You are not going to see the sine part, you're going to see the magenta part up there. That's it.
Do we need to erase our sign part?
You do not have to erase the sine part, because you guys aren't going to be able to get this without graphing sine. Do we understand that? Your brains understand how to graph sine. Your brains don't know how to get cosecant without graphing sine.
So as long as we prove that we have like the level in the correct case, it doesn't matter like how wide the parabolas are.
The parabolas are going to be based upon the asymptotes. Okay, do we all understand that, yes or no? Now, let's look at cosine. If you look at cosine, cosine has a max, a level, and then a level, a max. Do we see that? So what we have is one parabola opening down in the middle, and then we have the one-armed bandit of each side of the other one. Do we understand that? You will only have one side of the parabola on cosine. Do we get that, yes or no? Okay? You will not have the next level. You only have one half of the parabola. Good. Good. Okay, now, if we want to graph the secant, just so that we're aware, secant of x. This is what the cosine looks like. That's the cosine. There's the one-armed bandit. There's my full parabola. There's my other one-armed bandit. Do we see that, yes or no? So the green is going to be your cosine. If it's flipped, then what you're going to have here do we see that? Yes or no? That makes sense? Very good question. So, sine and cosine, secant, cosecant all have a normal period of 2 pi. Do we understand that? Okay? Now, tangent and cotangent, they have a period of pi. Write that down. They have a period of pi. Tangent and cotangent have a period of pi. Their starting and ending points are very different. Tangent is going to run from negative pi over 2 to positive pi over 2, whereas cotangent is going to run from 0 to pi.
So instead of dividing 2 pi by 2, you divide negative pi by 2.
Your period, same information, doesn't change except for instead of using 2 pi divided by the absolute value of b, you're going to use pi divided by the absolute value of b. it's going to be an increasing function that looks like x cubed. And cotangent is going to be a decreasing function looking like negative x cubed. What does x cubed look like? Spaghetti, right? Tangent and x cubed look like spaghetti. Cotangent is going to look like the negative decreasing spaghetti. Slide it over the y-axis. Okay. Instead of having a max level min, what you have is a low, medium, high, or a low level high. Okay? Low, medium, high, meaning the reason why we can't have a max level min is because it's an increasing function. It never has a maximum, does it? Do you understand that? It's never going to have a minimum. If it's increasing or decreasing, it's never going to have a max or min. So what we can do is get relatively high points, low points, medium points, right? The way we're going to do that is by simply using the lovely little amplitude. What you have going on here is it looks like this. Looks exactly like an x cubed function, doesn't it? Tangent looks exactly like x cubed because it goes right through the origin. Do we understand this? Cotangent does not look specifically like x cubed. It looks like x cubed shifted to the right. Do we all understand that? It's going to look like x minus 5 quantity cubed. You have to move it to the right 5 units. Do we all understand that? And again, we're going to have asymptotes. Your starting and your ending points are always going to be your asymptotes for both of these functions. Your starting and your ending points are going to be your asymptotes for both of these functions.
So cotangent doesn't go through all.
Cotangent does not go through the origin. Not on one specific cycle. Specific cycle that we graph, it does not go through the origin. It does go through the, if I move it horizontally, I can make it go through the origin, right? But generally speaking, the origin is going to be a lovely little asymptote for cotangent.
Would you say?
The asymptotes are starting and ending points. So the tangent, cotangent. Every starting point, every ending point will be an asymptote. Okay, let's try this. Let's do number 5. Y is equal 1/4 cotangent of x plus pi. Okay, we're going to treat our amp plus or minus 1/4. From our amp previously, what could we get out of that? Max level min is what we could get out of it, right? So what do you think we're going to get out of it now for tangent and cotangent? High, medium, low, right? High, level, low. Formulas are still the same. Formulas are still exactly the same. They don't change. Okay? So my positive amp is going to be 1/4. I don't have a C, so it's going to be 1/4. This is going to be 0. This is going to be negative 1/4. Do we all understand that, yes or no? If I had a C, I'd tack that on, I'd move it. Do we all understand that? Okay? From my AM, I'm going to get all that information. Okay? And the next thing I need to do is I need to have my period. Well, my period is going to be not 2 pi this time, but pi divided by the absolute value of b. Again, what is b?
1.
The number attached to the variable x, which is the angle. In this case, it's going to be 1, so I'm going to have pi divided by 1, which is just going to be pi units.
What happened to 2 again with your?
What happens to 2 pi? The 2 pi is only for secant, cosecant, and sine and cosine. Cotangent and tangent have a different period. Its period is pi units. That's why it's not 2 pi. Okay, from here we're going to get our interval. Our interval is going to be taking our period and dividing by 4. So our period is going to be pi divided by 4. Do you all see that, yes or no? Then how do I get my starting and my ending point? Well, what function am I doing? That's extremely important because tangent and cotangent have different starting points and ending points. Do we understand that? The starting point for tangent is negative pi over 2. The ending point for tangent is going to be pi over 2. What's the starting point for cotangent? 0. And what's the ending point for cotangent? Pi. So what we have to do is we're going to, starting point is going to be the jump in parentheses, x plus pi, is equal to 0. The ending point is going to be what? pi is equal to pi. Okay? So I'm going to start this thing at where? Negative pi. And I'm going to end this thing at 0. Now, how do I know if this thing is accurate? Ending point minus starting point has to equal your period. So my ending point is 0 minus my starting point, which is negative pi. And that's going to give me pi. Does pi equal pi? Yes, I know I'm right. We all understand that. Yes or no? So I'm going to come over here. I'm going to start making my little XY table. Okay, where am I supposed to start at? Negative pi. And what am I adding? Pi over 4. So negative pi plus pi over 4 puts me where? Visualize this. Visualize your lovely little unit circle. Okay, here's negative pi. It's going to be where? Negative 3 pi over 4. Now I need to add another pi over 4 to that. What's that going to give me? Negative 2 pi over 4, which is going to be negative pi over 2. Add another one. Negative pi over 4. And then add another pi over 4. That brings you back to 0. So can you see the visualization here? Where is this thing going? Where's this thing going? It is going around. We all understand that. We started right here, and we're trying to go all the way back over here. We see that, okay? More importantly, if I put that on my lovely little unit circle, or not my unit circle, my number line, where's all my graph at? Do you see I need to make the left-hand side long, not the right-hand side long? Okay? Because what I'm going to have here is negative pi, negative 3 pi over 4, negative pi over 2, and negative pi over 4. And then there's 0, which is right there. Do we understand that, yes or no? Okay, good. Now, what did I tell you whenever we do tangents and cotangents? What is the starting points and ending points? What are they always going to be? They're going to be asymptotes. Okay, we're going to have asymptotes at our starting point and our ending point every time. Which means I can come right over here and go right down like that. Right? And then, because this is cotangent, right? This is cotangent. My question to you is it being reflected? Is the amp negative? Is the angle negative? Are either one of those a true case? No. So is this thing going to be reflected in any manner? No. So what I'm going to have here is a decreasing function. So how can I have a decreasing function? Well, the only way I can have a decreasing function is if I have my high, my middle, and my low. My high, my middle, my low. What's my high? 1/4. What's my middle? And what's my low? Negative 1/4. So at negative 3 pi over 4, I'm going to be at 1/4. At negative pi over 2, I'm going to be at 0. And at negative pi over 4, I'm going to be at negative 1/4. So what I have going on here is something that looks like this. Do we see that cotangent graph, yes or no? Do we get that, yes or no?
Yeah, I didn't see why you put I negative 1/4.
I have 1/4 and negative 1/4. Because that's where we're using our high middle line. That's our amp.
So,
If you look at your function, with me. Okay, so if we go back to our lovely little graphing calculator to check all this so we can see it. And my function was 1 divided by 4, trig, cotangent, What was inside parentheses x plus pi? And hit enter. There it is. Now we're going to make this down to our 1 period. So we're going to go to menu, window, window settings, and where do I want this thing to start at? Negative pi divided by, what was my starting point? The negative pi? Just negative pi. And where do I want it to stop at? 0. And I want it to go by units of what? What's my interval? And I'm going to go ahead and hit OK. You see it? Now how do I know that I'm right? Well, I want to know that I'm going to have 1/4 and negative 1/4 of those specific values. So what was the one value that I had? I can go over here and hit Control T. Here's Control T. I'm going to hit Menu. I can do Table, and I'm going to do Table Settings. Well, I want it to start where? I want mine to start at negative pi. And I want it to go by steps of what? Pi over 4, right? Do we recognize the 0.25? Do you recognize the negative 0.25? Do you recognize this e to the negative 1/14? The negative 14. What's negative 14? It's almost 0. It's scientific notation. We all understand that. So we know that we're accurate now. You guys need to make sure you grab all of these, one complete cycle, complete your order pairs, all of that, and make sure it's done by tomorrow.
Can you write me a note before me so that I can go with someone? My own always takes all of it.
Not borrowed. Okay.